Alright, in this video we're going to talk about special triangles. We're going to kind of relate this back to the Pythagorean theorem a little bit. So we're going to talk about two special types of triangles. Alright, so first one we're going to talk about is what's called a 45, 45, 90. So here are the properties of it. So you can see here that we have a 40. When it says 45, 45, 90, that's literally 45, 45, and 90 right here. So when these are congruent, so they're the same, which makes these the same. So if these angles are the same, so whatever this is 5, that's also 5. And this is 5 root 2. Simple as that. So let's look at one. Let's look here actually. If I were to put 4 and 4 here, and I try to find x, and I left it in radical form, meaning I didn't give me a decimal. So if I did 4 squared plus 4 squared equals x squared, I got 16 plus 16 equals x squared. I got 32 equals x squared. Now you could plug in your calculator and get a number like 5 point something, but I want to do this. I want to leave it like square root of 32 and bring it down. 16 and 2 and 4 and 4, and I keep going, but I'd run on the screen. I got a pair of 4s here, so that means x is going to be 4 root 2 because I have a pair of 4s. And if you kept going, you're going to have two groups of 2. 2 times 2 is 4, and the 2 left on the outside or inside. So you see that's exactly what it is. So what happens here? And I'll give you a handout in class, but to go from here to here, you simply just multiply by root 2, which means you literally just put it right next to it. So let's look at a problem. So here you go. So simple. Remember, you're in a 45, 45, 90, your legs are the same. What I mean by legs is that's a leg, and this is a leg. So if this is 10, this is also 10. And this is 10 root 2. As simple as that. Next one. 7, once again, 45, 45, 90. So we've got this is 7, and this is 7 root 2. Once again, 8. We're going to put a number here, 8 and 8 root 2. There you go. And remember, once they have 45s here, we can say this. Alright, just because this is moved around a little bit, we still have a 45, 45, 90. 45 right there, this must be 45. So 14 on the right, 14 up top. Which makes this 14 root 2. Same thing. Alright. So next one's a little more complicated. I'm going to do this. This is 8. Now, when we're going to go backwards for hypotenuse, we would multiply by root 2 to get to 14 root 2. Now we're going to go this way. We're going to divide by root 2. Alright, so what we're going to do here. First, let's do a problem like this. I'm going to do it like this. Pretend this is 8 root 2, and then I'm going to take it away and show you what happens. This is 8 root 2. It's easy. It's 8 and 8. Okay, pretty simple. But since I took this off, we can't do 8 and 8. What we must do to go from here to here is divide by root 2. So 8 divided by root 2. Now, in math, they don't like things to be on the bottom like that. They don't like 0 on the bottom, as you know. They also don't like numbers like this. These are called irrational numbers. So this is what you have to do. You have to do what's called rationalize the denominator. So you're going to multiply top and bottom by root 2. So 8 times root 2, it is not 16 or square root of 16. If you do that, you are wrong. Those aren't like terms, so I have to write 8 root 2. Square root of 2 times square root of 2, it gives me the square root of 4. Square root of 4 is 2. So now I have two things down here. I have two things. I have the 8 and I have the 2. I'm allowed to divide those. 8 divided by 2 is 4, so that means 4 root 2. There we go. 8 divided by 2 is 4. So let's recap. We divided by root 2. That's right here. We realized, because I taught you that we cannot have root 2 in the denominator, so I multiply top and bottom by root 2. 8 times root 2 is simply just 8 root 2. Root 2 times root 2, square root of 2 times square root of 2, is going to give me a 2, because that's square root of 4, gives me 2. So, and then I have 8 root 2 over 2. I can take 8 divided by 2 and get 4. The root 2 would not change. That 2 is not going to change. Alright, let's do another one. Same thing, I'm going to divide by root 2. Oops, square root 2. So 7 divided by root 2. I'm going to rationalize the denominator. So top number times root 2 and bottom number times root 2. So 7 root 2 all over, remember this comes out to be 7 root 2 all over square root of 4. Square root of 4 is 2. Now we have 7 over 2. Now we cannot touch that because 7 divided by 2 is not a whole number. So there's my answer for x and y because it's a 45, 45, 90. Alright, same thing. I'm going to divide 4 divided by root 2. So, once again, I have square root of 2 in the denominator. I need to multiply top and bottom by root 2. Square root of 2. 4 times root 2 is just 4 root 2. Root 2 times root 2 is square root of 4. I'm going to get 4 root 2 all over just 2. It's not the square root of 2, it's just 2. 4, now we got right here, 4 divided by 2 is simply just 2. And then we don't forget about that root 2. Right there, and that's the answer for both of them. Alright, so sometimes you're going to get problems that look a little odd, like this one. So what we need to do, once again, remember, this is now my leg. So in order to go from here to here, we need to multiply by root 2. So let's take 2 root 2 times root 2. Now remember, if you remember all the way back from first semester, we multiply the numbers on the outside, so 2 times 1. 2 times 1 is 2. Square root of 2 times square root of 2 is the square root of 4. So if you know square root of 4, okay, let me think. Square root of 4 is 2. And this 2. 2 times 2 is 4. So that means A must equal 4. And if you remember, we just did a problem that had the hypotenuse 4. Right there. There's my 4 hypotenuse. Look at that. There's my leg, 2 root 2. We just did the same thing. 2 root 2 and we got the hypotenuse 4. Now this is the same one here, so that's 2 root 2. Alright, so now let's change it up a little bit. I got 2 root 6. So if you remember by rule, I'm supposed to take 2 root 6 divided by root 2. Okay, once again, I'm still going to multiply top and bottom by root 2. But now I'm going to take 2. I can't do anything with this 2 because this number in front is 1, but I have a 6 there. If you remember anything, I can take 6 times 2 and get 12. We're going to use that in a second, but we have square root of 2, square root of 2, and the square root of 4, which is 2. I have 2 on top and 2 on bottom. Those cancel out. I have the square root of 12. Now, please don't leave it like that. I can simplify it. I can break it down as 4 and 3 and 2 and 2. I got a pair of 2, so 2 square root of 3. And there we go. And I know that this is the right answer because if I took 2 root 3 times root 2, the 3 would turn into a 6, and there's my 2 root 6. Alright, let's move on. Alright, special triangle number 2. A little bit more challenging to remember because in the 45, 45, 90, my legs are the same. And I simply just get root 2. But this one's different. It's a 30, 60, 90. You have to identify which one's the smallest, middle, and largest. So you can see here I have x. That is across from the smallest number, 30. 60 goes with root 3, and 90 goes with 2x. So let's look at this. So, and you're going to get a worksheet thing in class. To go from here to here, you just multiply by 2. To go from here to here, you divide by 2. To go from here to here, you multiply by root 3. To go from here to here, you divide by root 3. I will never go from here to here. That'll never happen. You always go to or from the smallest. So let's look right here. So 2. First thing you identify is that this is the 30. That means this is the smallest size. So we are now given the smallest one. So the problem we're working on right now is this point right here. We are given x. Okay. So that means to go from my smallest to my medium one is simply just take 2 root 3. That's the correct answer. Because I simply just multiply by root 2. Oops, root 3, sorry. To go from here to here, I multiply by 2, which makes that number 4. And that's it. Now, they can give you all these different things and all that kind of stuff. But I have 60, this must be 30. So it's across from here. So that means this is my smallest. That's my x. This is my x root 3. That's my 2x, something you better memorize. So to go from here to here, this is 8 root 3. From here to here is 16, because I took 2 times 8. Alright, now some more challenging problems. We are given the largest number, so what we need to do is go to our smallest number, which is right here. To go from here to here, if you look back, guys, here's my problem. If I go from here to here, I'm just going to divide by 2. So that's exactly what we're going to do with the problem we have right now. So let's divide by 2. 60 divided by 2 is 8. So there's my answer right there. Once I go here, I'm going to go here. I'm just going to multiply by root 3. That's simply 8 root 3. That's it. That's all I got to do. So now, we are still given the biggest number. We must go from this number to here first. So that means I must take that number and divide by 2. Simply just take 8 divided by 2, 4 root 5. Nothing too hard. But the next one's a little more challenging. To go from here to here, I multiply by root 3. So when I multiply the 4, it would still remain a 4, but I would take 5 times 3 and get 15. And there you go. Alright, 10, we must go here first. Go to the smallest one. Divide by 2. You get 5. Right here. By root 3. 5 root 3. Alright, last one. This one's the easy one. 5 root 3. To go from here to here, you just divide by root 3. Or in essence, just get rid of that root 3. So you get 5. You go from here to here, times by 2. So nothing too hard. You got to know what you have and how do you always got to go to the smallest one first. And then you can go to the next one. Alright, it says the hypotenuse of a 30, 60, 90 triangle is 8. Find the other side. So let me do this over here first. So this is 30, 60, 90. And the largest side is 8. Okay, pretty simple. So we go from here to here in a 30, 60, 90 divide by 2. So that's 4. And I go from here, just times by root 3. So 4 root 3. That's my answer for the first problem. Here, the side length of a 45, 45, 90 is 12. Okay. If you remember, 45, 45, 90 means both... Oops, wrong number. In a 45, 45, 90, my legs are 12. And then the hypotenuse is simply just 12 square root of 2. Alright, more examples. So, 45, 45, 90. Once again, our legs are the same, so that's 9. And then this is just simply 9 root 2. Nothing too complicated. Right here, we are given the smallest one. So that means x has to be 3 root 3. I'd like to go from here to here is just root 3. Go from here to here is just multiply by 2, which makes that 6. It's really the same rules, guys, just over and over and over again. You can just remember the 2 rules for 45, 45, 90, and then about 4 of them for 30, 60, and 90. That's not too bad. So this is the largest one. To go from largest to smallest, I divide by 2. So that's 11. And to go from smallest to medium, I just include a root 3 next to it. Alright. In a 45, 45, 90, if my hypotenuse has a root 2, just like this one does, to go from hypotenuse to side, just get rid of the root 2. 6. 6. But now, this one doesn't have a root 2. It's just a 20. To go from here to here, I need to divide by root 2. So 20 divided by root 2, multiply that by root 2, 2, 20 root 2 over 2. So that means it's 10 root 2. Here, to go from here to here, you just kind of erase that root 3, so 5, and 10, because we multiply by 2. 6, this is another one just like the one before. We take 6 divided by root 2. Got to multiply top and bottom by root 2. Got 6 root 2 divided by 2. 3, so it's 3 root 2 for both of them. This one, 8. This is my smallest one. To go from here to here, just include that root 3. And here's my 16, because I multiplied by root 2. Alright, last example. 11 root 3. To go from here to here, you just erase that root 3. Go from here to here, you just multiply by 2. So this one, 2 root 6, you divide by root 2. You're going to get 2 root 12 all over 2. These 2's cancel out. I'm left with root 12, but it would be nice if you simplified that down to 2 root 3. Both of them. I think we did that example earlier. All right.